In our next section, we're going to look at the configuration of RIP-NG, which is RIP for IPv6 routing in JunOS. And we'll see that it's basically almost identical to the RIP version 2 configuration. The only exception is that we're essentially going to be using the keyword RIP-NG as opposed to using the regular RIP keyword. So this means that it also applies, or it also requires a routing policy, because again, the default export policy is going to be to deny any updates. The default import policy is going to be to permit. So we should be receiving things inbound without configuring any policy, but when we go to look at the outbound updates, we're going to see that those are going to be filtered by default, which is actually still the opposite in this particular slide. Let me go ahead and change that around. And during break, someone had a question. Why do you, or how do you enable RIP on the loopback, where normally in the case of iOS, you would need to have a network statement that matches the loopback, or in the case of XR, you need specifically to enter the interface statement that is matching against the loopback under the RIP process. In the case of JunOS, it's always going to advertise what you specifically define under the policy. Now, essentially, what I had done before, and we'll see this also with RIP-NG because it's going to be a very similar configuration. Let's say that we start with a policy. Let's look at SRX1. And we're going to configure a policy statement where we're going to go to global config or config mode. And we're going to edit policy options, policy statement, and we'll say that this is going to be RIP-NG. Under this, we're going to have a term. And actually, we don't even need a term because technically, I don't really need any other statements beyond this. We can just use it as the default. I'm going to say that set the from protocol is RIP-NG, and set the then to accept. So basically, we have a policy that says, if the protocol is RIP-NG, then we're going to accept it. We're going to allow it. Okay, we're then going to apply this to the RIP-NG process, and then it's going to apply outbound to the different neighbors. So let's say first off that we're going to apply this on. If we look at SRX2 in the, or SRX1 in the diagram, let's say that we're applying it to these three interfaces, so GigE 00012, 23, and 24, and we're applying this as our outbound policy. So we're going to go up to top edit, protocols, RIP-NG. We're going to set a group. We'll say that this is RIP-NG group. And it's going to be on interface, neighbor interface, neighbor GigE 00012, 23, and 24. And then we're going to set the export policy to be RIP-NG. If we top show pipe compare, we see we're doing two main things. We're defining the policy that's saying if it is RIP routes, we're going to allow it. Then we're going to advertise those out these particular interfaces. Notice that we're not listing the loopback though. Let's say commit and quit. And then we're essentially going to do the same thing on the other routers, but we're going to match it on different interface numbers. Now, in terms of regular iOS, this would simply be at the link level. So if we were to go to, let's say, CSR1, we would just go to global config, we would go to interface gig 1.12 and say IPv6 RIP, give the process a name, like number 1, and then enable it. But we would also need to do this at the loopback and any other interfaces that we want to enable the process on. So let's say we do it on CSR1 and CSR2. On CSR2, this is going to be on the loopback, on gig 123, gig 134, and so on. So we're basically doing the same thing as we're doing under JunOS. It's just that we're doing it at a different part of the parser hierarchy, where this is configured directly under the interface as opposed to be configured under the RIP process. Okay, next on SRX1, if we look at the show route table inet 6.0, which again is the global IPv6 table, we should see that we start to receive RIP-NG routes inbound. So we can see that we have a route to router 1's loopback, which is CSR1. We have a route to CSR2's loopback, which is 2001::3333. These are coming inbound via RIP-NG. Now, if we look at what we're advertising outbound, so let's go to the CSR side and let's look at the show IPv6 route RIP. Right now we don't see anything. Let's check it from the other side too. We see, from CSR1's point of view, we see what particular links? We see 3333, which is this loopback, and then we also see 10.134, which is this interface. So why do we not see that connected link, and why do we not see this loopback? Well, the reason is that when I configure the policy options, I said match the protocol, and the protocol it's coming from is RIP-NG. This would be the equivalent in iOS of the difference between looking at the show IP route RIP and the show IP route connected. So in the previous example, I was configuring the routing policy just to say accept without any conditions, which means that it's matching both your connected interfaces and your dynamically learned routes. Where specifically in the case of JunOS, they called the connected interface the direct route, as opposed to what we call the connected route in the case of iOS. So this means that if you wanted to advertise the loopback, and if you wanted to advertise the other connected interfaces, we need to add that match protocol direct statement under the routing policy. So if we look at the show config policy options, this previous one, which was just saying permit, was allowing everything. Now we're filtering it based on the outbound protocol. So it's not to say that RIP is enabled on the loopback by default. It's that we are defining manually what routes do we want to advertise. So do we want to advertise routes that we learned via the RIP process, or do we want to advertise our directly connected interfaces? So by default, that's not set. We need to manually define it under the policy statement. So we're going to go to config. We're going to edit our policy options, policy statement RIP-NG, and we're going to set protocol, set from protocol, direct. And commit and quit. This is the equivalent, again, of our connected interfaces. So if we now show config protocols and show config policy options, you can see from the protocol's point of view, essentially it's the exact same syntax. The only difference is the keyword NG between them. Then from the policy options, we're saying that we're including any routes that were to come in from the RIP process and our directly connected interfaces. The end result of this should be that when we look at the routing table from the other routers, that we start to advertise those connected links plus the connected loopback. So pretty straightforward implementation. The big thing to remember about this is that you just have to define the policy. Now, when we look at OSPF and ISIS, we don't necessarily need to define the policy, because normally when you do flooding with devices in your area, you're assuming that you want to have the same copy of the link state database. But in the case of RIP and in the case of BGP, since they're effectively distance vector protocols, and you can influence the hierarchy however you want, then you need to explicitly say what do you want to advertise, what do you want to receive. But again, in the case of RIP here, import policy is permit, the export policy is deny.